Hello, and welcome to the relearning for applied triangle sum and exterior angle theorems to solve problems. Please make sure that you put your name, the period that you're in, as well as the date that you're looking at this. If you are looking at it at home, you can write these on a separate sheet of paper. If you need to have the paper, it's in the back of room 1029 in the blue box. In this standard that we're looking at in here, there's two main parts we're going to be looking at here. One is classifying the triangles by the sides or by the angles, and then the second part is actually finding the angles. And there's some basic properties that we're looking at in here. The first part, though, while we begin, is we'll just get some names in here. An isosceles triangle is a triangle with two sides equal. Two sides equal. That means that when we're drawing our triangle, we can put two slashes on here, and that says that those two lines are equal. It doesn't say anything about the third, and we'll find in just a little bit it says something about the angles. But at this point, we're looking at just saying that the two sides are congruent. They're exactly equal. An equilateral triangle, this is a triangle with three sides equal. So when we're doing this in here, we're looking at this and we're seeing a triangle. And this one, we know about all the sides. We're saying that all the sides are equal. And once again, once we know all the sides, we can say something about the triangle or about the angles. But right now we're going to be looking at just the sides. An equilateral, lateral means side, equal sides. This is what we're looking at in a triangle. A scalene triangle is a triangle. So we saw 2 is isosceles, 3 is equilateral, and a scalene is a triangle with all sides different. So basically it's saying nothing is the same, 2 sides are the same, and 3 sides are the same. So we have a word for all three of them. Scalene is none, isosceles is 2, and equilateral is 3. We have a way to be able to identify the triangles in there. If we have all triangles, all angles less than 90 degrees, then we can say that the whole triangle is acute. So every angle has to be less than 90 degrees, and then we can say that it is an acute triangle, because we know that the definition for acute is less than 90 degrees. And obtuse, in the triangle, we can only have either all angles acute or two angles acute and one angle obtuse. So we can't have more than one angle obtuse, but we can have one angle obtuse or greater than 90 degrees. So if we were looking at that, we have our angle that's greater than 90 degrees, and then it forces our other two angles to be acute angles, but that doesn't really matter if we really want to make this so we can see we have one angle that's obtuse and the other two are acute. So these are both obtuse angles. And equal angular, we have that word equal in here, we have the word angular, and we're looking at a triangle that has all the same measurements, every single one of them. So when we're looking at this, those are the words that we're looking at when we're classifying them. So we can have an acute isosceles, where it means that all the angles are less than 90 degrees and all two sides are equal. We can have an acute equilateral triangle, meaning that all the angles are less than 90 degrees and all the sides are the same. We can have a scalene obtuse, which means that the sides are different and that we have at least one angle open greater than 90 degrees. We use these two names to go back and forth. The ones that we're most interested in here are these: isosceles, equilateral, and equiangular. All right, so in part 2 is the part where we're calculating and we're putting together our angle values. So when we have in here, one of the properties that we know is that if we have all the values in here, x, 109, and 23, we know that everything inside a triangle always adds to 180 degrees. So when we're going to solve this, we have x plus 109 plus 23 equals 180. So when we do that, every angle inside a triangle, it doesn't matter what kind of triangle it is, it all adds to 180 degrees. X plus 132 equals 180. And then we subtract 132 from both sides. X equals 48. So the measurement of this angle is 48. And then we put our symbol up in the air of our degrees. That's our units. And that's part of it when we're looking at it in here. This angle measurement is X, and therefore the angle is 48 degrees. Here we have the same type. It says find the measure, this means measure, or amount of the angle A. Well, here's our angle A. And even though we have different ways of forming these in here, that we have all our angles have some information inside, so we can all add them up to 180 degrees. So we have 9x minus 3 plus 11x minus 5 plus 48, and that all equals 180 degrees. So putting this together, we have 20x plus 40. 48 minus 5 minus 3 is plus 40. It equals 180. When we're going to subtract 40 from both sides, so we have 20x equals 140. Divide both sides by 20, and x equals 7. X equals 7. 140 divided by 20 equals 7. So when we're putting this in here, our x value is 7. So now that doesn't ask us in here for our value of x. It says the measure of angle, A. So we plug in our 7. 9 times 7 minus 3. 9 times 7 is 9 times 7 is 63. And then we're going to take 63 minus 3, 60. So our measure of angle A is 60 degrees. 60 degrees. So you have to find x. In the first one, we asked for x only. In the second one, we asked for the measure of angle A, so you have to plug it back in. But you solve them both the same way by adding up all the values on the inside. And number 3 is one that's interesting because it has our markings to remind us for our isosceles triangle. So this triangle is missing some information. So what we know about this is that this triangle here and this triangle are equal. Is this angle, this side, and this angle are equal together. We know that when we looking at a triangle, we can say that the angles across from the sides are equal. So for an isosceles triangle, angles opposite the sides are equal. So we have in here also our marking for our 90 degrees, but we're talking about these two down here. So this one's missing, so we can actually say that this is 2x plus 3, because these two are the same. They're they're opposite from our line segments. So as we're looking at this here, these angle measurements, we can once again just add them all up. 2x plus 3 plus 2x plus 3 plus our 90 equals 180. That's 4x plus 3, and 3 is 6. 6 plus 9 is 90 is 96 equals 180. Subtract 96 from both sides. 4x equals 84. 4x equals 84. Divide both sides by 4. X equals 21. 21. So if we were to plug this in, we would see that the value for this and for this would be exactly the same. Exactly the same. So that's one way we can do this. If these are given two different informations, we can also set them equal to each other. So the angles opposite the sides are equal. Opposite, opposite. All right, turning the page over here. This one here tells us that all three sides are the same. When we know that all three sides are the same, we know that the values of each one of these sides is congruent. And that forces actually all these angles to be exactly the same. Just like an isosceles triangle, this angle and this angle are equal. We now have almost like a double isosceles. This one and this one. This angle, and we'll say this angle are congruent. So we have our two sides right here. It doesn't matter. So we're taking all of these values. So we're saying something plus the same something plus the same something equal 180. We could call that x, x, x. They're exactly the same. Each one of these has to be the same because if they're congruent, they're cross multiply. The opposite angles are congruent. And now we have three lines congruent, so we can say this one and any one of these are also congruent. So it means all three are the same. 3x equals 180. Divide both sides by 3. X equals 60 every time. So an equilateral triangle is an equal angular triangle. They are exactly the same. One deals with the angles, but once you have all the sides the same, it forces all the angles to be the same. The last bit we're talking about in here is when we have what's called an exterior angle. It's on the outside. It's not inside. Now there's more than one way that we can find them. We can see that these angles right here are supplementary. There are supplementary. This is just what we did in the very, very beginning of the year. We could see that. We also could figure it out by saying all three of these angles add to 180. We could find this one here and then going backwards with the supplementary angle. But really what happens is that we have 48 plus 87 equal x. This angle and this angle equal the outside angle. 47 and 87 are 135 degrees equals x. Now let's do it the other way with maybe a different color marker. So if we were to look at this and we were to say that we have 48 and 87, and then there's a value right here, we'll call that question mark. So 48 plus 87 plus our question mark should equal 180. They're all on the inside. They're all on the inside. So we have the same thing. We have 135 plus our question mark equals 180. Subtract 135 from both sides. Question mark equals, oh, what is that? 180 minus 135 is 45. So our question mark is 45 degrees. If we know our question mark and we know that these are both supplemental, we can say this plus this should equal 180. Well, we just said that this is 135. 135 plus 45 equal 180. So you can find it more than one ways. But what I really want you to notice is that these two furthest away interior angles equal one exterior angle. Okay, so why don't you try the last of these and let me know how you do.